Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This question wants us to divide two polynomials, p of x and d of x. These are called rational expressions, these ratio of polynomials. And there are two ways to divide. One is called synthetic division, the other is called long division. Synthetic division is generally preferred because it's a little faster. But synthetic division can only be done when the denominator is linear. So you can see in this case the denominator is a linear equation. X minus 4 is a straight line. And so we can actually use synthetic division. I'll start with that one over here on the left side. I'm going to do this both ways. So you start by making like a little corner, kind of like, and you put, if x minus 4 is a factor, then positive 4 is a 0, and that's what you want to, sorry, this is moving around. Okay, so if x minus 4 is a factor, then 4 would be the 0. You want to put the 0 there. And then we fill in the coefficients here, which would be 1, 0. See, there's a placeholder for the x squared term. This is the x cubed term, x squared term, 6, 5. We bring down the 1. And then 4 times 1 is 4. We add them together. 4 times 4 is 16. We add them together. 16 and 6 is 22. So then 4 times 22 is 88, and 5 is 93. That's our remainder. And so we would express the answer this way: x cubed plus 6x plus 5 over x minus 4 is equal to x squared plus 4x plus 22 plus the remainder, 93 over x minus 4. And that's the way we do synthetic division. So a lot of people forget this first step where you just bring down that leading coefficient, and then the rest of it is just multiply and then add, and then multiply again and then add, and multiply again and then add. Okay, so for long division, this is just set up a little differently. It looks more like traditional division, the way you learned in grade school. So x minus 4 goes here, and x cubed plus 0x squared plus 6x plus 5 go up here. Okay, so up top we're going to put an x squared here. And that's because I want to put something up top, and when I distribute it, I get rid of this cubed. So let's distribute the x squared. So it's going to give me x cubed minus 4x squared. And now we're going to subtract. And here is this, people make this mistake so many times that I've gotten in the habit of putting a big bracket around it and putting a big negative in front of it so that you can remember and not make any sign errors. So this is, because we're subtracting, this is going to become 4x squared. Plus 6x plus 5. Now we want to get rid of the 4x squared, so what's going to be coming up here on top is 4x, because when we distribute the 4x against the x minus 4, we're going to get 4x squared. And then minus 16x here. Once again, we're going to subtract. So I do this to just make sure I don't mess up. So 4 minus 4 is 0. And then we have, you can see we're going to negate, a double negative here is going to give us a positive 16 and positive 6. It's going to be 22 plus 5. Okay, then once more, we want something up top to distribute through the x minus 4, and that's 22. So 22 times x is 22x. 22 times negative 4 is negative 88. And we're going to subtract that all the way through there. So 22 minus 22 is 0, 5. This becomes positive 88. And that becomes a 93. Remainder. And now to give the full answer so that the teacher can't possibly complain about your work, you're just going to say x cubed plus 6x plus 5, that's our numerator, divided by x minus 4. Now here, we just read this out. It's going to be x squared plus 4x plus 22. And then the remainder, you could see I like to put a box around the remainder. I just like to do that. And then it's going to be plus 93 over x minus 4. And you see we get the same answer whether we do it with synthetic division or with long division. But you can see that the synthetic division is faster, which is why it's preferred. But remember, you can only do it when the denominator is linear. So that's it. That's the way to do these rational expressions where you have a polynomial divided by another polynomial. So I hope this was helpful to you, and I'll see you again next time. Bye-bye.